Okay, this video is an introduction to limits. In this video, I'm going to give you two examples that give you some intuition for what a limit is. They actually will not look like the limits that we'll calculate in this class, but it's just to kind of give you an idea of the idea of a limit. So the first one is I want to draw a regular polygon. So this first picture here is a triangle, a polygon with three sides, and I'm just going to increase the number of sides. So if I do four sides, then I get a square. Let me zoom in a little bit here. Get a square. If I do five sides, I get a pentagon. If I do six sides, I get a hexagon. And I'm going to keep going. So I'm just going to increase the number of sides, and I'm going to let the number of sides get big. Okay. So I might have a 10-sided figure. I might have a 20-sided figure. I might have a 50-sided figure. And what I'm going to ask is, what shape are we approaching? So for any fixed number, so say n is 5, I have a shape, a pentagon. And as n grows, you know, if I let n be 10, I have a 10-sided polygon. If I let n be 50, I have a 50-sided polygon. And what I'm asking is, what shape is this approaching as I let n get larger and larger? And it's sort of, the guess that I think everybody would have is that I'm tending towards a circle. You know, if I put in 1000 here, it looks a lot like a circle. And that's the right intuition. As n gets larger and larger, the polygon gets closer and closer to a circle. And so we can say the limit of this process is that I'm approaching a circle. And we'll say more precisely what we mean by approaching later, but the intuition in this example is clear. One note here that I want to make is that even though it is correct to say that we're approaching a circle, if we do any particular n, even if it's very large, so see this n is 50, it looks a lot like a circle. For any fixed n, the object that we have is not actually a circle. Maybe it's getting very close to a circle, but it's not actually a circle. This is a 50-sided figure, and if I sort of zoom in far enough, we can see that there's like a corner right here. So you see, so for any fixed n, even if n is 10 million, it's a 10 million-sided polygon. It's not actually a circle. There will be corners, even though the angles will be sort of very obtuse and it will look a lot like a circle, but it will not actually be a circle. But it is still correct to say that as n gets larger and larger, what we are approaching is a circle. So we never actually get there, but we are approaching it. Okay, so that's the first example. The second example is something called Xenos paradox. I just want to, Xenos paradox sort of says, like, if I want to say drink a glass of water, well, first I have to drink half of it, and then I have to drink half of what's left, and then I have to drink half of what's left, and then I have to drink half of what's left. And so, how can we kind of ever finish the glass of water? And so I'm going to represent kind of how much of the glass of water we finished by a fraction. So kind of first I have to drink half of my glass. So we drank 50% of the glass, and then I have to drink half of what's left. So half of what's left is a quarter of the glass. And so at this point, we've drank 75% of the glass of water. And then I have to drink half of what's left. So that's an eighth. So at this point, I've drank 7/8 of the glass of water. And then I have to drink half of what's left. And the number of time, I'm gonna let the number of steps that I do go to infinity here, or get very large. And so I'm gonna write that in a way using summation notation. So if you don't know what this means, it's okay. We can talk about it later. But it's a way to write out these fractions so I don't have to type every single one. So if I do one step, so this number on top is the number of steps I'm going to do. So if I do one step, I've drank 50% of the glass. If I do half and then half again, I've drank 75% of the glass. If I drink half and then half and then half again, I've drank 7/8 of the glass, and in 4 steps, I drank 93% of the glass. And we're just going to let the number of steps get very large here. So like if I drink half of what's left 10 times, then what I have left is something very small. It's 1/1024. If I drink half of what's left 15 times, what I have left is a very, very small amount. And you can ask, well, what is the limit of this process? If I keep drinking half of what's left over and over, well, the limit is that I'm going to drink the whole glass, right? I'm getting closer and closer to finishing the whole glass. This sum is getting closer and closer to 1. If I just add half of what's left over and over and over again, I'm getting closer and closer to 1. And so you could reasonably say that the limit of this process, the limit of this sum is 1, and it is. But again, note that for any fixed number, even if I do this 15 times, yes, I'm very close to 1, but I'm not actually at 1. If I do this process any finite number of times, I might get increasingly close to 1, but I'll never be at 1. But it is still correct to sort of say that this process is, this sum is converging towards 1. And we'll make this more precise exactly what approaching means, converging means later.